I was going to do probability today, but I'm going to skip the probability questions today, and next week I'm going to focus fully on only probability questions for the entire class, right? So, and then after that, I want to do a full review on statistics past paper questions only. All right, so here we have, right, the base, the core of what we plan to do today. Whenever I ask you to draw a graph today, right, it will either be a sine, tan, or cosine graph. Now, for this particular format, I use cosine, but obviously it could have what? Sine in place of the cosine here, or it could have what? Tan. Usually, well, sometimes, I shouldn't say usually, there will be a number touching the sine, tan, or cosine. We're gonna give them names. His name will be Albert, right? So whoever is touching the sign, who comes before, right, and we all know that there's a secret multiply here. Whoever comes before the sine, tan, or cosine, that number, his name is going to be Albert. Cosine, well, it's usually theta. Remember, sine, tan, and cosine were made for what? For angles. If there is a number touching the angle, right, his name will be Billy. And if you have something being added or subtracted to Billy inside the brackets, remember, anything inside these brackets that come after the cosine, both of them belong to the cosine. If there's a second item inside the brackets, right, his nickname is going to be Carl. And after, if there's somebody added or subtracted outside the brackets at the end of the question, its name is going to be Dora. Okay? Now, take down everything on the screen. Do not screenshot it. And then I'll go through it quickly, and then we're going to try some questions, right? Just let me know when you're finished so I can begin to talk about what's in front of you. Whenever we have to modify a graph, we're either going to be moving it, like shifting it horizontally, or changing it vertically, like the height of it will be affected. Now, we all know the x-axis, right? The x-axis deals with horizontal movement. On a graph, the y-axis is vertical movement. So anything associated with the x will change the graph horizontally. It can either move the entire graph to the left, or it can move the entire graph to the right. The point is, anything dealing with x affects the horizontal orientation of the graph. Anything dealing with the y coordinates on a graph could either move the graph up, or it could what? Move the graph down. In other words, it would affect the vertical portion of the graph. If you notice that everything inside the brackets, right? Everything inside the brackets, that's Billy and Carl, they affect the x coordinates. If you look at the notes, right? They deal with the x coordinates of the graph, meaning that they will only affect the horizontal orientation of the graph. Also, it just so happens anything dealing with the x coordinates, that's once again Billy and Carl, whatever the number tells you to do, or what you think the number will do, it's actually the opposite will happen. For example, if Billy is 2, you might think that you have to multiply all the x coordinates by 2, right? Now, Billy deals with multiplication, right? But you do the opposite. If B is 2, it is actually multiply by a half. The opposite of 2 is a half. And if B is a half, it is actually multiply all the x coordinates by 2. You just flip it now. And the same thing for Carl, right? Carl has to do with addition and subtraction of the x coordinates. But it's the opposite. If this C value is a positive value, it is minus that value from the x coordinates, even though if C is positive. Common sense would say that If C is positive, you would add the X values. But in reality, we just have to minus it. Right? Don't try to think about it too much. Just follow the instructions. And if C is a negative value, like if this was -3, if Billy was if Carl was -3, you would actually go to all the X coordinates and add 3, right? However, the items outside the cosine, like A and D, which is really Dora and Albert, they only, right? They only affect the Y coordinates. If you look at it, they only affect the Y coordinates. The X coordinates are unaffected by them. But they actually make sense, meaning that if Albert is 3, you just multiply all the Y coordinates by 3. You don't have to do the opposites. And if Dora is +10, you literally add 10. You don't do the opposite for that one. All right, so Albert and Dora are normal, and Billy and Carl are the opposites. Whatever they say, you have to do the opposite. Right? So let's move on to the first question, right? Right, so I need everyone to draw this graph for me. Let's do a makeshift graph. By the way, you notice your x-axis is in angles, right? Like 90 degrees, 180 degrees, 270, and 360. Sometimes in the exam, instead of putting the angles in degrees, they could put it in what? Radians. So they could put pi on 2 instead here. This is pi. This is 4 pi on 3, right? And this would be what? 2 pi, right? Right. 217 radians is 3 pi on 2. Small mistake there, right? So I just letting you know, right? The x-axis could be in radians instead. So let's draw the first graph, right? Your most basic graph. If the examiner asks you to draw fx is equal to sine theta, right? Remember, theta is the angle, and also for fx, they don't have to use fx, right? They can use the letter y. Y and fx for all purposes is the same exact thing. How does a sine graph look, right? A sine graph looks like this. I'll draw it and I'll point out anything that you need to note about it. Sorry, one small mistake there, guys. Sorry. It's kind of hard to draw. Right. This is it. This is how a sine graph looks. It's supposed to look like a wave. This is supposed to be curved. This is not a straight line. So a sine graph starts at 0. It cuts the origin, and it only goes up to 1 at 90 degrees. And then it hits back the x-axis at 180. And at 270 degrees, it goes down to -1. And then at 360, it hits back the x-axis, right? Now, in reality, right, and let's let you know, if you were to look behind the y-axis, right, it would actually look like this. It's a continuous wave that goes on for infinity. So at -90 degrees, and yes, it's possible to have -90 degrees, it goes down to -1, right? So in fact, if you had -180 degrees here, it will go back up like this. You just have to continue the pattern. It's a continuous wave, like a wave in the ocean, right? Right, but I'm not too concerned about this right now. I just wanted to point that out to you. So on the graph here, this is fx is equal to sine x. I'm going to color code it for you, right? So sine is black in my diagram. Right. So the next one that you have to be able to draw for the examiner, right? I'll use red for this one. Suppose the examiner asks you to draw cosine theta, right? It's really supposed to be theta, put x by mistake. Now, cosine is a little bit different from sign, a little bit different. At 0, it's not at 0. Cosine actually starts at 1. And it goes like this. At 90, it hits the x-axis. At 180, it dips the -1. At 270, it cuts back the x-axis. And at 360, it rises back up to +1. Now, obviously, if you continue this backwards, it will look something like this, right? But once again, right now, I'm not concerned about the negative angles. So the red one is cosine x. Let me know when you're finished with those two drawings. And then I have to clear the screen. Actually, no, I could draw tan x on this same graph for you guys. But let me know when you finish with these two. To understand tan, you have to know about Pac-Man. In Pac-Man, when you go to the end of the screen on this side, what happens? Do you all remember? When you go to the end, to the right-hand end of the screen, what happens? Right. You come through this side. It's like a portal. When you go through the right-hand side, all of a sudden, you just end up coming through this side. Right? Great. So that is how Pac-Man is almost like a portal, right? So where am I going with this, right? If you go higher and higher and higher, right? Say you have 100, 200, a million, a billion, a trillion, or I talk about the y-axis, right? So you go up a billion, trillion, a gazillion, dillion, right? Eventually, what number you're going to reach? And eventually, you're going to reach positive infinity because it's getting what? Higher and higher and higher, right? Eventually, you're going to get so high, right? It's gonna like you pretend it's going to be like Pac-Man. When you go too high, you end up coming out from the underneath of the screen from minus infinity. So it come like this. So just watch me do this on the screen, right? I'm drawing a line here, right? I'm going higher and higher and higher and higher. And eventually, I'm going to reach the top of the screen, right? Now, when I reach the top of the screen, I'm not going to be able to go anywhere. But the Pac-Man effect takes place. I will go to the top of the screen and then appear from the underneath of the screen, right? So as you go higher and higher and higher, you reach positive infinity. And when you reach positive infinity, you emerge from the underneath, which is from negative infinity. So I'm going to use that concept now to draw the tan graph. However, you need to know one word, ASYMTOP. I hope I spelled it correct. This word is called asymptote. What is an asymptote? An asymptote is a line in maths that you get closer and closer to, but you never, ever, ever actually touch it. The only that like you get ridiculously close, like you get closer and closer and closer and closer. Like if this is my asymptote here, I'm getting closer and closer and closer, but I'm never, ever, 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 ever allowed to touch it, right? So I'm going to put some asymptotes on the screen here. It's these dashed lines. Everyone, I assuming everybody's seen these dashed lines, right? There's one going through 90 degrees. There's one going through 180, 270, and 360. I'm going to use green for the tan graph. This is how a tan graph looks. It starts at 0, right? And it goes up and up and up and up, right? Up and up to what? It's a curve, by the way, right? Towards the first asymptote. But then no matter how close I try to get, I never, ever, ever, ever actually touch it. So I get closer and closer and closer to the asymptote. The only time that this green line will touch the asymptote is when it reaches infinity. So it's theoretical, right? Because nobody has ever reached infinity as yet. It's assumed that when you reach infinity, this green line will touch the asymptote. Now, when it reaches infinity, the Pac-Man effect takes place. It emerges from the underneath like this and goes through 180, and then it tries to go touch the asymptote going through 270, but it never, ever, ever does until it reaches infinity. And when it reaches positive infinity, the Pac-Man effect takes place. And it emerges from the bottom to make a curve through 360 degrees. That green graph is tan theta. Right, so draw tan theta for me, and yes, I want you to draw the dashed lines, which are the asymptotes. Right, when you're finished with that, we're going to try some official past paper style questions on this question. Right, so we have two questions we're going to do. We're going to do the one on top first, right? So 3 cos theta. Quick question, right? This tree is which name? Is he Albert, Billy, Carl, or Dora? That's Albert, right? Albert is the person, right, who touches, who comes before the sine, tan, or cosine, right? Now, let's go back to the first slide here, right? Let me just show everybody something, right? I'll just do this a couple times, right? Right. So when it's Albert, right, you multiply only the y coordinates by Albert, right? So only the y coordinates are affected. The x coordinates are not affected. Right, so let's go and apply that to the question. The first thing you have to do, and I want you to do this in the exam, right? If they ask you to draw something cos theta, I want you to draw the cosine theta graph first, the regular boring cosine theta, but do not draw it dark. Just take your pencil and draw it real light. Let me show you. Let me give you an example, right? So I'll try to draw something light. I hope you all could see this, right? I hope it's not too light, but can you all see the gray there decent enough? In the exam, I just want you to make it barely visible. Can you all see the gray there? That's my regular boring cosine graph, right? That I'm just going to draw it in pencil in the exam. And then take all the key points. The key points are this point where it cuts the x-axis, down here, over here, over here. I call those the key points, right? The points at 0, 90, 180, 270, and 360. I call it key points. Now, obviously, the y coordinate here is what? 1. The y coordinate here is 0 because it's cutting what? The x-axis. The y coordinate here is what? -1. The y coordinate here is 0. And the y coordinate here, once again, is +1. So all we have to do, right, is go and multiply all the y coordinates by the key points by 3. Now, I know this is obvious, but I know somebody's going to make the mistake. Anything multiplied by 0 is 0. All right. I know somebody's going to get tricked with that. All right. So let's go here. The y coordinate is 1. 1 multiplied by 3 is +3. Over here, the y coordinate is what? 0. 0 multiplied by 3 is 0. Over here, the y coordinate is -1. -1 multiplied by 3 is -3. I wonder if I have -3 here. Yeah, I have -3 here. It's down here. The y coordinate here is what? 0. 0 multiplied by 3 is 0. And over here, y coordinate is +1. 1 multiplied by 3 is 3. So all I have to do now, the key points, I join them. I try to keep the same, general shape of the curve. But the curve, you can see that when you join it, it gets a little bit more steep. This is my answer. That's it. Everyone okay with that? This is an Albert question. We just visit the graph and all the y coordinates at the key points, multiply it by 3. Draw it, draw the answer, and let me know when you are finished. And when you're finished, draw a next blank graph over here. Right? If you notice, the x coordinates were not affected. The graphs, both graphs go through 90 on the x-axis, right? 270 on the x-axis, right? The lowest point is at 180 for both of the graphs. You know, the x coordinates were not affected at all, just the y. The second question, sorry, one second. The second question, the one with the sign. What kind of question is this? Albert, Billy, Carl, or Dora? Is this a Dora question? Carl question? What is it? It's a Dora question, right? So if you read the instructions for Dora, right? Let's go back. Remember, I said I will go back every once in a while, just until we get familiar, right? Dora says whatever the d value is, right? It only affects the y coordinates, right? But this time Dora has nothing to do with multiply. Dora is just addition and subtraction. So if Dora is positive, right? We go to all what? The y coordinates and add what? We add whatever value it is. And if it's negative, we would have what? Subtracted. So let's do that. All right. Right. So it's a sign graph. So what you need to do is draw a sign graph first, but draw it real light. Okay. So only like you could like basically see it. Right. Right. And we all know how to pinpoint the key points already, right? These are the key points. So let's go to all the y coordinates and subtract 2. So the y coordinate here is 0, right? Because it cuts the origin. 0 minus 2 is minus 2. So this point drops to where? Minus 2. Over here, the y coordinate is clearly positive 1. 1 minus 2 is minus 1. So this 1 goes down to minus 1. He is easy. The y coordinate here is 0. 0 minus 2 will take you down to what? Minus 2. This one here, the y coordinate is minus 1. Minus 1, and we said we would minus 2. Minus 1 minus 2 is minus 3. So he going down to minus 3. And 0 minus 2 is minus 2. If we connect all of these points, doesn't it look like the whole graph was shifted downwards by minus 2? Like it had an earthquake, and this thing just dropped. The whole graph just dropped down by what? Minus 2 into the ground. That's your answer, right? Take your time, draw it. Let me know when you are finished. All right, so we're doing the one on top first. The one on top is cosine 2 theta. What type of question is that? Is it a Albert, Billy, Carl, or Dora question? Right. It's a Billy question. Now, if you look at for Billy here, if it's a 2, right, anything inside here only affects the x coordinates, right? And we suppose to multiply all the x coordinates by 2. The y coordinates, the height and depth of the graph, the vertical orientation will not be affected, right? So let's have a look here. And this one is a little bit difficult, not too difficult. Compared to the rest, it's a little bit of a headache, right? So whenever it's 2 theta, right? a lot of people think the graph will actually get twice as big. But since 2 really means to multiply by half, you know, when you multiply something by half, it will get what? Smaller. In fact, the graph does get twice as small. It does get twice as compressed. It's like you have a spring like this, right? And somebody pushes this way and somebody pushes this way. The spring will get more compressed. Now, the height of the spring doesn't change. It's just, it gets more compressed. So you have more up and downs for the same space. So let's see what happens here. What we have to do first is draw the regular boring cosine graph first. So let's do that. If you look back in your notes, you will see that your cosine graph looks something like this. Just give me a few seconds. All right. Right, so that's regular boring cosine. Now let's look at the x-coordinates. The x-coordinate here is 0. The x-coordinate here is what? 90, 180, 270, and what? 360. Now remember, the height of the graph and the depth of the graph is not going to change. We have to visit all the x-coordinates and divide it by 2. 0 divided by 2 is what? 0. So this point remains unchanged. 90 divided by 2 is 45, right? Now, if here's 90, in the middle will be what? 45. So this point moves to where? The middle. 180 divided by 2 is what? 90. 270 divided by 2 is 135. 135 will be exactly between 90 and 180. So 270 divided by 2 is 135. And 360 divided by 2 is 180. So look at what happens to this graph now, right? It will look like it got compressed. Does it look like the graph got compressed? Like somebody pushed it this way? Like this was a wall, and somebody pushed this point to reach over here, no, par x here. He became over here. So you notice the whole graph fit in half the space because the whole space was 360. The original graph took 360 to fit. But now the whole graph fits up to where? 180. Right, so while you're take that down, let me just explain it back again. Right. So the second question is a Carl question. Now, I just did this on purpose, right? Pi on 2 is really how much degrees? It's really 90 degrees, right? Now, I could have written theta plus 90 degrees, but I was just trying to be difficult because the examiner, instead of writing the angle in what? Degrees, they could put it in radians. So for those who don't know, pi on 2 is the same thing as 90 degrees. Now, since this is a Carl question, right? Carl only affects the x-axis, but it affects it in the opposite sense, right? It affects it in the opposite sense. So even though it says add 90 degrees, you're already supposed to do what? Minus 90 degrees from all the x coordinates. So that is exactly what we're going to do, right? So let me just clear a little space here, right? The first thing we have to do is obviously draw the regular boring sine graph. And like I said, I want you to draw that very, very light in the background, right? So only basically you could see that, right? All your key points here. Here's positive. That's supposed to be positive 1. I know it looked like it's supposed to go up, hit here at exactly positive 1, hit here at 0, hit here at negative 1, and here at what? 0. So what we're going to do now, we're going to visit all the x coordinates and minus 90. 0 minus 90. 0 minus 90 will give us what? Minus 90. So he will get drifted back to minus 90 because we minusing 90 from everybody. Over here, the x coordinate is 90. 90 minus 90 would put us where on 0. You have 180 here. 180 minus 90 will give us how much? 90. So this 180 gets drifted over here. Over here, the x coordinate is 270. 270 minus 90 is how much? 180. So he gets drifted over here. And 360 minus 90 is what? 270. So he gets drifted over here, right? I should have drawn this one on top here, so it doesn't look too cluttered. Here, the x coordinate is 90. You what? Minus 90, it goes to 0, right? That looks a little bit neater there. So all you have to do now, I'm going to use blue here, right? I'm going to draw it. One second, guys, I draw this one wrong. This is supposed to get drifted back over here, hovering over the 0, right? So the 90 reached the 0, but the height does not change. Second, guys, I just want to keep it good here. Right, so let's draw this in blue here, right? You all see what happened here? Look at the gray graph. And let me draw it slightly deeper here. Right. Let's see if I can remove all of these arrows here. You all notice something? Look at the gray graph. That's the original graph. Doesn't it look like somebody tie a rope here on the graph and pull it 90 degrees backwards? Because the 0 ended up where? At the minus 90. But it dragged the whole graph. Pretend the graph, the gray graph, is a solid graph. It cannot be stretched. But somebody pull it backwards by 90 degrees. Does it look like that? Like the whole graph has been pulled backwards by 90 degrees? Let's see if I can draw that for you here. Try to depict that. And have somebody here pulling. As you rope there. Right, so that's them sweating there. And they're pulling it backwards by 90 degrees. If it was negative 90 degrees, they would have pushed it forward to the right by 90 degrees instead, right? But Carl works the opposite. If it's positive, you move it backwards. If it's negative, you just move it forward. That's just how it is. Click it. In this question, it has, oh, sorry, I wanted to make sure I do this one, sorry. This one here, before we go to the more complex one, this one here is what situation? Which person? It's a Carl question again, but this time it's a half. No, this is a Carl question, right? Remember, the general format is what? A like cosine, like you have B theta plus C plus D. If it's directly touching theta, it's a no, this is a Billy question. Everyone saw that? Almost everyone answered wrong. This is a Billy question. Because instead of having 2 theta, it has what? A half theta. Everyone agrees with me? Y'all alive on that side? Anybody? What I want you to do is try this question for me. Try this question. So it's a Billy question, right? Try it, and when you finish, I know you're not going to be able to send your answer, right? But let me know when you finish attempting the question. I will work it out, and then you tell me, hey, if my answer and your answer is the same. Good luck. And sign. Get gray here, right? So it's gonna look like this. Go down here, go down to -1 and 360. Now remember, Billy only affects the x coordinates. So we're gonna multiply all the x coordinates by 2, not a half, where we always do the opposite, right? So we flip the half and we get 2. So over here, the x coordinate is 0. 0 multiplied by 2 is 0. Over here, the x coordinate is how much, right? The x coordinate is 90. Now, 90 multiplied by 2 is 180, right? So this point shift to over here. The height of the graph is not supposed to be affected because we're only dealing with x coordinates. Over here, the x coordinate is 180. Now, 180 multiplied by 2, you can try it on the calculator, is 360. So this point shifts to 360, but we've reached the end of the graph. This graph only goes up to 360. So that means the graph is like this, which makes sense. Let me explain why this makes sense. You see, when it's a half, the graph is supposed to get twice as large horizontally. Now look at the original graph. The original graph has 1 up and 1 down. And for that to fit, it took a full 360. For 1 up and 1 up, 1 up and 1 down, sorry, it needed 360 degrees to accomplish that. But now the graph has gotten twice as long horizontally. So that means only the up part can fit because the up part needs 360. Obviously, if this graph went on to 720 degrees, 360 multiplied by 2 is 720, the down part would have been able to fit. How much people had something like that, right? The graph got stretched horizontally to become twice as large, right? And well, if you extended the graph to 720, well, I guess that's good, right? But in the exam, they will give you a certain size of graph, and you only go to the end of their graph, right? So who didn't get it correct? Well, at least you have the answer now, and for those who got it correct, well, congrats. Right, so this one here, right? Now, this one I wrote it like this on purpose. You see how I have theta on 2 here? Theta on 2 is the same thing as a half theta because n theta on 2 means we're dividing by 2. So that's the same thing as a half theta. Which 2 are involved here? Which 2 names? This is who? This seems to be Albert and Billy. Right. Notice that Albert and Billy question. Remember, it's a half theta. So that half is being multiplied by theta. So go back to your notes and just quickly refresh your memory on what Albert means. This is Albert here. And this is Billy. Now, Billy values a half, right? And usually Billy's have to do the opposites, right? Right. The first thing we have to do is draw who? Cosine, regular boring cosine. So everyone start off with that now. Draw regular boring cosine here. Oh, let me show you. When you're doing these questions, do not do both at the same time. That's a really, really bad idea. The next thing you should, since we cannot do both of them at the same time, right? We either have to do Albert first or Billy first. Let me give you some advice. You see the people who are inside the brackets, which is really Billy and who and Carl, you should probably do them first. Because do the hard part first. So in this question, since we don't have a Carl, but we have a Billy, we should probably do Billy first. I want everyone to do the Billy part first, which means you're going to take the cosine, and since it's already a half theta, you're going to multiply all the x coordinates by +2. Remember, Billy is do the opposite. Go and multiply all the x coordinates by +2 and draw it in. And after we do Billy, we will modify Billy by applying Albert. So we're doing it in steps. Good luck. So what's going to happen, when we apply Billy, the graph is going to get twice as big horizontally. So we have to multiply all the x coordinates by what? 2. Right? So we multiply all the x coordinates by 2. Here the x coordinate is what? 0. 0 multiplied by 2 is still what? 0. Right? Over here, the x coordinate is 90. Right? 90 multiplied by 2 is 180. 180. Sorry, and over here, this one, the x coordinate was 180. 180 multiplied by 2 is what? 360. Now look at this, huh? For this graph, right? If we kind of split it down the middle, right? The original graph. The whole graph took 360 to fit, right? Half the graph, which is piece of a up and piece of a down, right? That is going to take a full 360 to fit now, because right now it's taking 180 to fit, but the graph is getting twice as large. So what's going to happen? That piece of the up and piece of the down, right, is going to take a full 360. So this portion here got stretched and it needed a full 360 to fit. How much people have that? The graph got twice stretched horizontally to become twice as big. How much people have that? Let me know in the chat. The dark gray graph, well, I'm going to change my color to red now, right? We have to go and multiply all the y coordinates by -3, and not +3, -3. The the y coordinate here is +1. 1 multiplied by -3 is -3. So this 1 multiplied by -3 goes down to -3. Over here, the y, we'll go over here because we can't approximate this point, right? Over here, the y coordinate is what? 0. 0 multiplied by -3 is -3. I mean 0, sorry, what's your percent again? 0 multiplied by -3 is 0. Over here, the y coordinate is -1. -1 multiplied by -3 is +3. It's almost like the graph got reflected, but not only reflected, right? The up became down and the down became up, but it also got steeper. So it got reflected and steeper. The red one is your final answer. right? You notice I kept the kind of curvature shape now. How much people got that before me? Because I realized some people probably went ahead now, well, without waiting on me. Let's move on, right? And also the questions will come on sine and cosine, like to modify them. They don't, as far as I can tell so far, in none of the past papers, they have asked you to modify a tan graph. There's always a sine or a cosine. So I want you guys to try this one, right? Now, this one here, which two are involved? Albert is definitely involved, but that minus one, who is that? Right? Kenya, look back now, look back, look back. Come guys, Salamatu, correct, right? You notice this minus one not in the brackets, right? So if it have brackets, only the theta belongs to the cosine. Right, this is Albert and Dora. Right, so this is the Albert and Dora question. In my experience, right, if you have to choose between Albert and Dora, even though it really doesn't matter which one you do first, I would suggest you do the Albert first, right? So draw your regular boring cos theta graph, apply Albert first, and when you get that answer, then apply who? Dora. Even though it's possible to do it with doing Dora first, right? It really, right? So, but this is just my advice. That is all it is. Good luck, and let me know when you're finished with the entire question. So we said we was gonna do the part with Albert first, but I have to draw my cosine graph first. So let's do that. Get that out of the way. Cosine looks like this. Right. So for Albert, we have to multiply all the y coordinates by -2. So the y coordinate here is 1. 1 multiplied by -2 is obviously -2. So he goes down here. The y coordinate here is 0. So 0 multiplied by -2 is still what? 0. The y coordinate here is -1. -1 by -2 is +2, right? 0 by -2 is 0, and 1 multiplied by -2 is -2. So you can kind of see that this graph became what? Kind of reversed, right? The down became up and the up became down, but because it was -2, it not only reversed, right? But it got a little bit steeper. How much people got up to there for Albert? That's the Albert part of the question. Good there. All right. Now we have to apply Dora. Now, Dora is straightforward. She only affects the y values. And if it's -1, you just -1 from all the y values. Now, you can use a little bit of common sense here, right? Now, if I say you are going to all the y coordinates and minusing 1, that means it's only going to affect what? The height of the graph, right? It doesn't affect the horizontal orientation, only the height. So if I am minusing 1 from all the y values, won't the whole graph drop downwards by -1 like an earthquake? Like the ground was removed and the whole graph drops by -1. Or we can do the calculation one by one. Here the y coordinate is -2, -1. You'll get -3. So he moves down to -3. Over here, the y coordinate is 0. It goes down by -1 because you're minusing 1. Here, the y coordinate is 2. 2 minus 1 is +1. Y coordinate here is what? 0. 0 minus 1 is -1. And over here, the y coordinate here is what? -2 minus 1 is minus 3. When you connect this up, it will obviously look like the whole graph dropped downwards, right? By minus 1. How much people got the red graph? Right. Now, this one here, I did it on purpose, right? You all notice I put Dora in front, like that positive 2. That should go where what? Last, right? Also, is there an Albert value there? Like, for example, like this positive 2, right? This supposed to already be like minus cos theta. And this positive 2 is not connected here, right? How much is the Albert value? Right, you all don't fall for that trick in the exam. Eh? Albert is minus 1 because minus cos theta is minus 1. Now, so this is a Albert and Dora question. Again, do the Albert part first and then followed by the Dora. Right. So that was the only trick in this one. Even though we just did an Albert Dora question, I just didn't want you to fall for the trick because the examiner could switch it around and mix up, where Dora is. When you finish with the entire question, let me know. Right? Hey, what? Before you start, since this question, the last one was a cosine one, let's change this one to cosine now, right? Let me change it to sine, right? It ain't gonna make much of a difference, but I don't want it to be too redundant, right? So try this question. I'm modifying it so it's not too boring. Good luck and let me know when you are finished.